that the sooner you start memorizing those, the better. Now, if you were able today to list 1 to 10 squared, do you have to work at memorizing those, or do you already know them? You already know those, right? So we're going to talk about different things that you're going to be doing. So as you look at this, if you please open your workbook and your notes to A1, that first lesson. And again, if you did not put your first and last name yesterday on the top of yours, please make sure you put that out in the front. And usually what you're going to see on my lessons, as you look at these, and you may have seen this something like this last year, it'll say, listing our standards for this. I can identify and evaluate square roots, I can understand the concept of square roots, and I understand squaring a number and taking the root. So, if each of these sides is a 1 by 1 square, the area, we say, is 1 square unit. Do you agree? There's 1 square unit. Here, I would like you to write right beside that the side is equal to 2 centimeters. Now we'll put 2 units. 2 units. What would our side here have been? 1 unit, right? So when the side was 1 unit, the area was 1. When the side is 2 units, and sometimes I'll have people, how do you get 2? There's 3 dots, right? We're talking about this length, that's 1 unit, 2 units, right? So 2 units on the side, the area is 4. So it says, how long are each of these sides? We've just answered that, right? Our sides were 1 unit and 2 units. So it says make a prediction. If I drew a square with an area of 16, what should the side length be? I want you to write that down right now. If the area was 16, so it's this whole big square, right? 16. What is our side length? Please write it down, put side length. Check with the person in front of you or behind you and see if you agree. So check with the person behind you or in front of you. You might check with both. Did you have, if it's 16, right? If it is 16, what did you have for the side length? Did everyone check with the person in front or behind them? You can check with the person next to you too, okay? Did anyone change after they talked to or looked at their partners? That's okay. So, how long was the side? When this is 16 square units, the side length was? 4. Look back at your About Me sheet where you put 4 squared. Keep that sheet out. What did you have for 4 squared? 16. If the area is 16, what do we know about the side length? 4. When the area was 4, what is 2 squared? 4. So there's the reason I wanted you to start writing those numbers and thinking about them. There is a relationship between those that we are going to use. So it says to find the area of the square, you multiply the 2 sides together. Since they are the same side length because it's a square, we usually say you square the side length. So when the side length was 4, right? 4 squared equals 16. So it says find the area of each of these squares. So you have 2 squares down below there. Right now, we might say our side length here is what? 3. Over here, they're telling us the side length is 7 meters. So please tell me, if we do this, if we square the side squared, what is our area? Side squared, what is our area? So, yours, you want to write this word area down. So please write the word area equals. You can put it right in that box if you like. You can put it in the box or behind the box. Area equals we're going to put what? Area has to be equal to the side. And what are we doing with the side? Squaring it. So 3 squared, which equals 9. And we are going to put square units. So what is that next one? Area, we write down equals 7 meters squared. 49 meters squared. So we're going to kind of be going back and forth between area and side length today is what we are going to be looking at. The other thing we are going to be doing in this first week is one of the things I'm going to be talking to you about is we need to get your height in centimeters, your arm span. We're going to do some different measurements because at the end of the year we do this project, but I always think it's kind of interesting in 8th grade to do the beginning of the year and the end of the year. So we'll kind of be doing that because some of you change drastically this year. Some of you not so much, or some of you like you grow. So, top of that next page, you need to memorize. Okay? I am going to put up this really short video, and in this video, you're going to see what is a perfect square. Okay? So, as you watch this, one of the things I'll have students do is as they start to memorize these, is like some of these, the 1 to 10, you might know, right? And some of you got up to 13, and we did 14. 15 is 225. 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 is 361. Do you have to write all those down? Not right now. You're going to have them in this note, right? You have this with you. You can open this up and look at this, okay? I'm going to show you this video really quickly, and then as you're watching that video, so everyone should be on page 2 of their notes so that we can fill in your notes as you are watching this. And it's a pretty short video.
What is a perfect
square?
A perfect square is a number that is the square of an integer. In other words, we could take an integer and square it, and that resulting number is a perfect square. Now let's take an example. 16. 16 is a perfect square because it can be broken down into 4 times 4. In other words, we take the integer 4 and multiply it by itself. Or we take 4 squared. When we take 4 squared, that resulting number of 16 is a perfect square. Now there are an infinite number of perfect squares. But let's list off just a few to get an idea of what they look like. 4 is a perfect square. Because it can be broken down into 2 times 2. In other words, we take the integer 2 and square it and get the perfect square of 4. 9 is also a perfect square because it can be broken down into 3 times 3. We already know that 16 is a perfect square. It's 4 times 4. 25.
No, I didn't mean to do that.
What is a perfect square? A perfect square is a number that is the square of an integer. In other words, we could take an integer and square it, and that resulting number is a perfect square. Now let's take an example. 16. 16 is a perfect square because it can be broken down into 4 times 4. In other words,
let's get to about where we were.
25 is also a perfect square because it's 5 times 5. And 36 is a perfect square because it's 6 times 6. Let's take a couple more. We have 49 is a perfect square because it's 7 squared. 64 is a perfect square because it's 8 squared. 81 is a perfect square because it's 9 squared. And 100 is a perfect square because it's 10 squared. Each one of these numbers on the left-hand side of our equal sign is a perfect square because it can be broken down into the square of an integer. So remember, if you have the square of an integer, that resulting number is called a perfect square.
So when we are taking a look here, sometimes you're going to see me write in these boxes, and other times I have had students tell me, Mrs. Thompson, you're writing like I don't know how to read cursive. I write in cursive sometimes. So, sometimes you don't have to fill in exactly in the box. You might be writing down here outside the box, but the box is so that I can show you what we put in. So, what is a perfect square? I'm hoping that some of you put down a perfect square is what you get when you square any integer. Okay? If you didn't write this down, please write this now, like 1, 2, 3, dot, dot, dot. Meaning, as high as you want to go, right? We could have 52 squared, 52 times 50, right? Keeps going. The other thing that we want you to keep in mind is they are also the areas, okay? That is key. Perfect squares are going to be the areas of all squares that you can draw if the side length is a whole number. Do we have decimals in any of those ones that she talked about? Do we have fractions? No. Will we use fractions and decimals? Yes, but it will never give us a perfect square. Does that make sense? To get the perfect square, it always has to be a number like this. So if you didn't write this down, I'm going to give you a minute to make sure you put those words down. Especially here, and that it is that area of the square, right? And usually I'll kind of try and walk around and see that you have that filled in. And I want you to look down at the bottom after you've started filling that in. So on the bottom, they start talking about vocabulary. Key to our mathematics is our vocabulary. Most of you, I see a few people still writing. So it says if you know the area of a square, you can always work backwards to find the side length. Okay? So if I know the area, I can work backwards and find the side length. This concept is called the square root. That's on the poster. You see that big black square root. It's called the radical symbol. Okay? It says, in other words, if you take a perfect square and ask the number that was squared to get the number, that's called our square root. So the square root of a number is a value that when multiplied by itself gives us the number. So example, 4 times 4 equals 16, the square root of 16, which we write like this, the square root of 16 equals 4. So please write that in right below it. When you square 4, you get 16. When you take the square root of 16, you get 4. It says, no. What else gives us positive 16 besides 4 times 4? Negative 4 times negative 4, right? So it says negative 4 is also a square root of 4, meaning if I square negative 4, I can get 16. This is called a radical symbol. Not radical like, oh my gosh, your parents think you're radical because you believe one thing and they something else, right? Not that kind. It means that you can take the square root of that number. So it says A. Why do we use A? A stands for our area of the square, right? So this is area of the square. You write that right below it. You got a little room. Area of the square equals, this is going to be our side of the square. And the same thing goes here. This S stands for side is equal to the square root of the area. Okay? Is that kind of making sense? Top of the next page. some of you might have gone, oh, I'm getting this. This makes sense. I get this. So I want to find the length, and I know the area. Now you have that About Me page that you wrote those numbers down. So if you need to look at that, you can. You can also, as you are doing this, look at the page in front. So if you have your notes open this way, right, you can look at this. So area is 36 square inches. The side, I'd like you to write down side equals, and then you're going to put in a number and a label. So this is going to be your number. You don't have to write this down. This is going to be the label. Okay? Do that for each one of those. Once you have your 3, check with the person either behind you or in front of you and see if you agree with the 3 numbers that you wrote down. For me, the first one is going to be in inches. 36, I'm going to take the square root of 36 to find my side, which equals 6 inches. Okay? Do the next 2. You can use this table if it helps you also. Okay? So check those next 2. Area is 4. You can talk to your neighbor, check with them. What is the side? 144. What is the side? By all means, check with your shoulder partner, the person sitting right in front of you or behind you. I was looking at the second one. I should be looking at everybody. 4 square centimeters should be 2 centimeters. 144 should be 12. Please put the unit behind it if you didn't. So, should be 12 meters, should be 2 centimeters, should be 6 inches. Okay? The next part down. So again, when you memorize it says here, here's a list of the square roots with the perfect squares you're going to memorize. So you need to be able to memorize it backwards and forwards, right? So you need to know 64 squared, 64 is 8. You need to know that 10 squared is 100. You need to know 11 squared is 121, square root of 121 is 11. Okay, so you need to know it backwards and forwards when you are learning. So it says this next part, are negative square roots. Are there negative square roots? Yes. There are negative square roots. I want you to take a look what we have here. It says the number 5 and negative 5. If we square both of them, they're going to give us 25. For example, 5 times 5, negative times negative. If you remember from last year doing all your integer work, negative times a negative is positive. Every positive number has 2 square roots, positive and negative. 0 only has 1. The square root of 0 is 0. Okay? So, here's how you might have different answers on your homework or on your worksheet, okay, when you are looking at these. When you take a look at this one, you have the square root of 25, you might answer as 5, and because this negative is out in front, and then it says that, your answer here would be a negative 5, just a little different, okay? So a radicand cannot be a negative number. You can't have it negative underneath here. Okay? So there's no real number that will give us a negative answer. If you take negative times a negative, we get positive. When you get into algebra 2, you'll deal with these numbers. These come out to be what's called in mathematics an imaginary number. They're not real. That's why they use this word, no real numbers. It's imaginary. Just like that friend you had back in, when you were much younger and you had that kid you talked to in your head. That imaginary friend, we have that in mathematics for you at some point in time. Last page, if you would please turn in your notes for today. Do the first 3. The second 2 on here, the bottom 2, you have to keep them as fractions, no decimals. So keep as a fraction. First one, raise your hand. Who has my first one? Who do you get? 7 7. Going across, square root of 36. Somebody else, yes? 6. Negative square root of 100. Negative 10. 4 square root of 4 over 49. In the numerator, only the numerator, tell me. Only the numerator, what would you have? The numerator. 2, good. The denominator should be 7. If you haven't done that last one, do that last one now. Keep it as a fraction, right? Not bad. Same thing if you know that list of numbers. And if you did that, what do you have? What'd you get? 1 over 3, 1/3, right? So we're going to keep those fractions as fractions. So, your homework kind of looks like this. We're going to look at it in just a minute. This last one down says recognizing inverses. It says if you look at the two tables at the left, they show you that squaring a number and taking the square root of a number are, and the word I'd like you to write in, inverses. This means one operation undoes the other one, kind of like addition, subtraction, multiplication, division. 3 squared, you get 9. The square root of 9, you get 3. Another way to think about it is this. These two things right here, this and this, they undo each other. So if you square any number and then take the square root of it, it equals that number. It's a beautiful thing to recognize, right? I don't need my calculator if someone asks me, and I'd like you to just write this down over here. If I want to find the square root of 35 squared. Now, I would not want, if I didn't have a calculator, to figure out what 35 squared was and then take the square root. The beautiful thing about mathematics, some of you might not feel my beauty, but these two things undo each other. It equals 35. That's a great thing, isn't it? I don't have to use my calculator. I don't have to think about it. The square root of 35 squared equals 35. So I want you to do a couple more. I want you to do the square root of 28 squared. I want you to do the square root of 521 squared. Check with the people sitting by you or next to you and see if they agree or disagree. 28. The square root of 521 squared is a beautiful thing, isn't it? Just to be able to kind of know that. It's not like you have to take a lot of time. So now if you turn way back in your workbook, and if you want, one thing I have had students do in the past, because you're going to turn back, everyone should be turned in right now. It's on page 32, 33. 33. So sometimes what I'll have students do is I'll have them just fold this page over right before. Why? Because then it marks where their homework starts, right? Where the workbook part is. So that you don't have to flip back and forth, okay? So the notes are in the front. You are now at your workbook on your homework. So does the first one look like what we talked about? Find the area. Try to do as much from memory without a calculator. Ooh, this is a tricky one, right? The first two, they kind of look okay. We've seen those numbers, right? So what we are going to write right below each of these is area equals, and I am kind of a stickler. I want you to try and get used to using the units with it. So what you put for the first one? 16 centimeters. And you know what I'm going to have you do? I want you to write it out. I want you to put squared centimeters. And someone's like, oh, can I just use the centimeter too? And the problem with that is sometimes people think it also means to square the 16. So write it down now. Okay, so you'll do the next one. If you want to write it in the box, you can do it that way. Area equals. So, what do we have to do with the 1/2? We're going to do what? If I know this is the side, right? is 1 inch. What do I have to do with the side to get area? Area equals taking the side and doing what? Squaring it. I don't want a decimal. You're going to square the top and you're going to square the bottom. Do you know what 1 squared is? 1. Do you know what 2 squared is? 4. The answer is 1/4. 1/4 what? Square inches. Okay? The next part asks you, as you're looking at it, square each of the numbers. Here it asks you to find the square root, right? Square root is when you're thinking this, square root. This one is taking the number and squaring it, and then evaluating those last problems, okay? So, your assignment is doing 1 to 26 on this page. When you come in Monday and you did these questions, after you've done the first 3, where should you turn?
No.
To the answer key in the back and just take a look and see if you did it right, right? So you do 2 or 3, you turn to the back and you take a look.